FACET is an acronym for Future ATM Concepts Evaluation Tool, where ATM is Air Traffic Management. The software helps you evaluate various futuristic concepts to look at how things could be improved in the future. At the same time, it also looks at the current operations and helps you visualize different aspects of current operations. And so one can learn from what's happening today and develop concepts, explore concepts and develop concepts, and then implement them in FACET to see what the impact on the national airspace system would be.
With forecasters predicting that air traffic will double by the year 2025, developing next-generation air traffic management concepts to increase airspace capacity is vital to the continued growth of the nation. FACET is one of the main tools currently being used by NASA to study new airspace management concepts and evaluate their potential impact.
Think about an algorithm that we might have developed. How do we know that this algorithm is really going to do what it is supposed to do? So to test that, we have to take this algorithm and see in reality what the effect is. But we really cannot take an algorithm and go and tell the FAA or the air traffic controllers, okay, use this. Before we do that, we have to test it where we apply this algorithm and simulate what could have happened in a reality. That's where FACET comes in. FACET is a very powerful simulation tool where we can use these algorithms, decision support algorithms, to see how much delays could be reduced if you use an algorithm.
Working in collaboration with NASA's Ames Research Center, the Federal Aviation Administration, and other partners, UC Santa Cruz researchers are using FACET to explore a wide range of automation concepts. One of these concepts is dynamic airspace configuration, which uses advanced automation algorithms to dynamically reconfigure the national airspace, making it more efficient as air traffic patterns change throughout the day.
So in the U.S., the airspace is divided into these groups called centers, which are large regions across the continental U.S., and there's 20 of those, and within each center, it's subdivided further into sectors. And each sector is controlled by one or two air traffic controllers, and so they're responsible for the traffic in that sector. So one idea is, okay, well, what can we do to redesign that sector to flexibly account for changes in traffic? And if we can do that, we might be able to reduce delay or run the entire NAS much more efficiently. So if we come up with a new sector shape, we can put that into FACET, allow the planes as they currently fly or as they wish to fly through them. And what FACET's able to do is measure any number of workload metrics that allow us to say this new sector design is better or worse than the existing or some other sector design by this criteria.
In addition to dynamically reconfiguring sectors, researchers are also looking at ways to combine sectors in order to better optimize air traffic controller workload during off-peak hours.
There's also the idea of combining sectors, and a couple of us have looked at this, and this is currently something that goes on today. The existing sectors at certain times are combined, so one controller would be responsible for not just one sector but multiple sectors, and that's usually in times of low traffic volume. So we've looked at ways of doing this in a more systematic way. Right now it's currently done kind of in an ad hoc basis, but we've looked at algorithm approaches and optimal approaches that allow us to hopefully better combine these sectors during times of off-peak traffic.
Along with combining and reconfiguring sectors, researchers are also looking at more efficient ways to schedule flights. Traffic flow management seeks to use advanced decision support algorithms to optimize air traffic while taking into account changing weather patterns, current air traffic, airport capacity, and a wide range of other factors.
Traffic flow management is basically sort of planning how we should schedule the various aircrafts in the United States, so they can go from one airport to the other in a most efficient way. What Facet does is, if you take certain kinds of actions, Facet tells you what is the implication of that. So it could be used by traffic flow management people to say, if there is, let's say, bad weather in a place, what are the various options I have to avoid bad weather, and of those options, which is the best.
Through its advanced simulation environment, Facet is providing researchers with a valuable platform to conceive, develop, and test advanced concepts which will one day become part of the next generation air traffic management system. A system which will be safer, experience fewer delays, and provide a new level of efficiency in supporting growth in the United States well into the 21st century.